Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, solve a logarithmic equation. Question 10, change of base. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. If I could stick every single algebra student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to get your healthy dose of Algebra 2 by ordering and purchasing the Logarithmic Exponential series or the entire Algebra 2 Cram session. You have lots of friends, peers, classmates, and or colleagues who are taking Algebra 2 with you as well. Tell them to inbox me at memedicine@gmail.com so that they too can order and purchase the complete Cram session. You'll be glad you spread the word because they'll make great study buddies. All right, let's delve into the concept. Change of base. Solve a logarithm. Evaluate the log base 3 of 5. Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you are able to press pause and arrive at a solution, and if not, that's completely fine. In order to solve this logarithm, all you have to do is simply plug it into your graphing calculator. I'll be demonstrating on the TI-84 Plus series. Okay, so basically you have to turn the calculator on by pressing the on button. And if nothing was entered into your screen prior, it'll look like this. Okay, but if something was on there, you'll have to press clear in order to get it to look like this. Okay. All right, and so now what you're going to do in order to input the log base 3 of 5 is press math, and you'll be brought here. And then if you scroll up or down, whichever way you prefer by using the up or down arrows, you'll land on option A, okay? And in order to select this option, you'll have to press alpha and then math again to choose option A, okay? And after doing so, you'll get the log function where you can specify the base that you want to input, okay? So here we're going to input 3 because that's our base. And after pressing 3, your screen should look like this. And then you're going to press the right arrow to exit the base specification feature, and you're going to enter your power or your result here. Remember, a logarithm is kind of like an inverse well, it actually is the inverse of an exponential equation. So what you're shown, the number that you're shown is actually the result rather than the exponent, okay? And so our result specified in this question stem is 5. So you press 5, and then your screen looks like this. You press the right arrow again and enter, and then you get this answer of 1.464. For our purposes, we can go out to the thousands place. So if you round up in the thousands place, because the 10,000s place has a 9, you'll get an answer of 1.465, okay? All right. So alternatively, you can customize your solution depending on the method you prefer. And if you don't have a calculator that has change of base functionality, you can use the change of base property of logarithms to analyze this problem. So the change of base property of logarithms says that the log base b of x is equivalent to the log of x divided by the log of b. When we see a log without a base specified, we know this is the common logarithm that's available on most graphing and scientific calculators where the base is 10, okay? You could also use the natural log. It just has to be the same. I think in the ln function is also available here, right? So the ln is just log base e, e being Euler's number or the natural number, okay? Yeah, so it's the equivalent to the log, the common log of the power or the result divided by the common log of the base, okay? All right, so therefore, if we apply this to the log specified in our question stem, we have that the log base 3 of 5 is going to be equivalent to the log of 5, our power or result, divided by the log of 3, our specified base, okay? And we can go ahead and input this into our graphing calculator. So what we're going to do is hit log, then you'll get this function. It's the common logarithm because no base is specified. That means it's base 10. And now we're going to go ahead and hit 5. Okay. And then we're going to close out our parentheses by hitting the close parentheses button. And then we're also going to insert our division sign by hitting the division key. And we're going to hit log again as well so that we can go ahead and input the log of 3. So go ahead and press 3. Then you close out your parentheses once more. Okay, and then you go ahead and hit enter. And voila, you get the same answer as if you were to evaluate the log base 3 of 5, because this is basically the change of base concept, okay? That's why it's so neat. You don't always have to have the most up-to-date tools to get the correct answer, okay? And then alternatively, there's another method you can take, which isn't too different from the second. You can rewrite this in exponential form. Well, we know that this is our base, so, and we know that this is our result. Therefore, we can, but we don't know the exponent, so we're going to go ahead and call our exponent x. Yeah, so this is 1.6465 if you round up to the thousands place. And so our result is 5 is equivalent to base 3 raised to the x. The x value is what you're, or the exponent value is what you're always trying to solve for in a logarithmic problem, okay? All right. Also, although we've written it out in exponential form, we're going to go ahead and throw some logarithms back on this bad boy. Because the reason why we're doing this is to get rid of an exponent, we take the log, okay? So the log of 5, whatever we do to one side of the equation, we have to do to the other. So the log of 5 is equivalent to the log of 3 to the x. And according to the power rule of logarithms, if you take the log of a base raised to an exponent, as we're doing here, that's going to be equivalent to the numerical value of the exponent times the log, the common log of the base. Okay, so therefore, the log base 5 is equivalent to x times the log of 3 because we applied the power rule of logarithms to the right-hand side of the equation. Okay. All right, now what we're going to do is divide both sides by the log of 3 to solve for x, and we're going to flip it so that x comes first, and therefore we end up with x is equivalent to the log of 5 divided by the log base 3. And this also looks just like our change of base formula. So you would basically input the same exact information as you did for the change of base method. And you're also going to get that it's equivalent to 1.4649 blah blah blah, but we're simplifying it to the thousands place, and you get that your answer is 1.465, okay? And if you want, you can check. You can raise 3 to the 1.46. Well, I would do this answer. and you should get the answer 5, which makes sense because 3 to the first power is going to be 3, and 3 to the second power is 9, so you would guess that 5 is somewhere in between 1 and the exponent to yield a result of 5 is somewhere between 1 and 2. Okay? All right, thanks for tuning in. Definitely order the entire Cram session by inboxing me at memedicine@gmail.com. Good luck studying. Thanks for tuning in.